What's up? It's Medicosis Perfectionalis, where medicine makes perfect sense. Welcome back to my chemistry playlist. Today we shall talk about reversible reactions that go both ways and the famous or infamous Chatelier's principle. I actually like it. It is so easy. Here's a basic equation. A plus B will yield C plus D. Reactants are here. Products are here. The arrow has to be reversible. It can go forwards or backwards. Now I'll ask you a series of questions and your job is to tell me, will we shift the reaction to the right or will it shift to the left? Basically, what Chatelier's principle is saying is that whatever you do to the reaction, Chatelier's will undo it so that we can restore equilibrium. Think of it this way. If I added a ball here on top and then gave it a little push, what do you think it's going to happen? Zhoo! It's going to go downstairs from here to here, i.e. it will shift to the right. Now, question number 1. What's going to happen if I added more reactants to this side? Please pause. What do you think is going to happen? If I add more reactants here, I'm going to go zhoo. I'm going to push it this way so that products increase until we reach equilibrium once again. So by adding the reactants, you will shift the reaction to the right, which means you will favor the forward direction and you will get more products as a result. Question number 2. What's going to happen if I add more products to this reaction? Pause. Answer. By adding more products, we're going to go the other way, favoring the reverse reaction and creating more reactants in the process until we go back to equilibrium. Question number 3. I will decrease the concentration of the reactants. What's going to happen? Answer. Since I decreased the reactants concentration, this whole reaction will shift so that it can create more reactants to replace the ones that I removed, which means the reaction will shift to the left, favoring the reverse or backward reaction, favoring the creation of more reactants. Question number 4. I will remove products from the process. What's going to happen? Answer. We will favor the forwards reaction to create more products in lieu of what I've removed. Translation, we favor the forward direction. Question number 5. Let's put those reactants in a smaller container. What do you think is going to happen? If you put them in a smaller container, they will collide with each other more often. More collision equals faster reaction, and you will end up making C and D sooner than before. The shift was to the right. Another question. Let's put those reactants at a higher pressure. Go! What's going to happen? Oh, more pressure, faster reaction, more product formation, shift to the right, favoring the forward reaction. Last, the hardest part. What's going to happen if we add heat or remove heat? This depends on the delta H of the reaction. Suppose that the delta H of the reaction is negative. What do you think is going to happen? Please pause. If the delta H is negative, it means it's an exothermic reaction. Exothermic. Heat is exiting. Heat is leaving the chat. Heat is a product now, so we can write heat with the products. What's going to happen if I raise the heat of the reaction right now? If you raise the heat, it's as if you're adding a product. More products equals shift to the left, favoring the reverse reaction. Another question. Delta H is still negative, and I am removing heat from the system. I am lowering the temperature of the reaction. Oh, if you remove heat, it means that you're removing a product, which means the reaction will shift forwards to the right, favoring the forward direction, producing more products. Now let's try something different. Same reaction, but I changed the delta H into a positive number. Let's say positive 625 kilojoules. Whatever. It's a positive number nonetheless. What do you think is going to happen to the reaction if I add more heat? Think about it. Well, if delta H is positive, it means that this is an endothermic reaction. Endothermic. Heat is entering into the chat. Heat is a reactant now. Therefore, by raising the temperature of the reaction, it's as if you added more reactants. If you added more reactants here, we're going downhill to the right, favoring the forward direction. But if delta H is positive and I lowered the temperature of the reaction, what's going to happen? You're decreasing the reactants, therefore the reaction will shift to give us more reactants, to replace the reactants that we removed. And there you have it, Le Chateliers in less than 6 minutes. Smash like, subscribe, join my membership program. If you join the highest tier, you get access to more than 300 premium videos. Download my notes from my website, as well as my premium courses, or if you'd like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine and chemistry make perfect sense.